Hello, MinervaDB Athena attendees. Today we'll talk about a very exciting topic, MySQL 8 observability. But before that, let's briefly talk about observability as a whole. Right, so what is observability and why is it important? In the modern world, we are increasingly working with very complicated systems. And the change of such systems is often the issues in them just happens once in a blue moon, and it can be rather hard to repeat them in development and test environment to be able to understand what's going on, to troubleshoot and resolve them. And that means we cannot simply be testing systems in test environment. We need some good insights of production systems to understand what has happened and to make sure we resolve those problems so they don't happen again. In general, observability goes with some sort of a data capture, right? That observability data capture, which I would put into two different kinds. One is your ongoing data capture, which you run all the time in production, and that is something which needs to be light, so it doesn't cause a lot of overhead, but it also needs to be powerful, so hopefully you can use that data to resolve vast majority of the problems which you encounter in the system. And then also, if that data is not enough, right, if there's ongoing cases or something else, we may enable even additional data capture, right, more verbose, which we often can call debugging. Like debug log, for example, is that a very special additional data capture which comes with substantial additional overhead, so we don't want it to handle all the time. Another thing to think about observability is what often you need to have a comprehensive view. While we talk about MySQL observability in this presentation, you can generally focus on MySQL alone because MySQL operates within the system as a part of a system. So operating system, hardware, network, wherever the cloud provider issues are all going to impact how MySQL operates, its performance and stability, and so on and so forth. Also, you should be thinking about application issues and various background load issues as you are troubleshooting your system, right, or analyzing the data, which may impact how the MySQL itself behaves. With that, let's start looking at MySQL 8 in particular. Now, as we talk about observability as a way to capture the data, we need to analyze and resolve various issues. We can think about the data sources, right, as a core which allows us to have that great level of observability. And on this page, you see the list of the main MySQL 8 data sources, which are available in MySQL 8. Some of those are new and some of those are existed forever. Let's go through them and see what they are and how they're usable. Show status or show global status is a feature which existed virtually forever. Right? And it has been changing through the years, and by now in MySQL 8 there are more than 400 status variables which you can understand. Most of them are counters, some are gauges, some can be even tests, and they either have a session or a global scope. They are also available as a performance schema table if instead of show global status statement, you want to use access them as a table using full power of SQL language. So let's look at what those global and session are and what is the difference. So in this case, I see the variable questions both in a global and in the session scope. We can see what the number global is huge. That huge number is actually the number of queries this instance has handled since it started from all the connections, right? where the questions in a session scope is how many connections only my particular connection handled. So in this case, I probably had this connection open for a while, and that is why it has 153 queries. And that can be very helpful to understand both the global context as well how your system was impacted. At the same time, in MySQL, unfortunately, it is not so clean. So in this case, I am looking at some of the status variables in the session scope, but I can see the number of InnoDB rows deleted, inserted, and so on and so forth are huge, probably much larger than my session could have done. And this is because even though those values are reported in the session scope as well, these are actually only maintained as a global counters, right? And they are not available per session. In this case, MySQL did what I would think some questionable design decision, what they made the global counters available in a session status, not only in a global status. Now, when you use a status, you can use them as a poor man's profiler of the queries, right? How do we do that? Well, we can query their status counters before that, run a query, and then look at the status counters afterwards. So in this case, I did the select count star on the table, and we can see what handler R&D next was incremented by essentially as many rows as there have been in this table, showing what that query was executed through their index scan. That can be very helpful to really understand how exactly query was executed. Now, in this case, I am suggesting to do the math between the counters, but you also can do flash session status, right, and wherever to reset the counters, so you can avoid having to do the math and can just get the counters for given variable. This is also what is used can be used to populate something like vm-stat output for MySQL. Like in this case, I'm running MySQL admin extended minus I1, that means iterate every second, minus R, that means print the relative values, and it shows me now what I had, gazillion of queries since the start, which is the first line, and then 400 to 500 queries every second, which is helpful. But one problem you would say with this particular visualization is it only works for one variable to be used. With your Percona toolkit, though, you can sort of pivot the table where you can show the incremental values as columns, right, instead of rows. So in this case, using a tool from Percona toolkit called ptmax, I am getting 5 extended status outputs, which is used to produce 4 columns. One of them is something from the start, and then others show the incremental for different values since for every 1 second. So very basic, but very useful tool, and I would not ignore. The next tool is information schema. Information schema in MySQL 5.8 has more than 60 tables. Some are schema related, other are various performance statistics. For example, table contains information about various tables and views, right? As you can see on this page, contains a lot of various information. We also have a table called InnoDB metrics in performance schema, which is a table which has a similar functionality and similar behavior compared to the show status, but it's kind of more powerful. right? You can see, in addition to maintaining the counter, it contains the average value, it contains minimum and maximum value, and so on, and so on and so forth, right? And also you can use this table to really enable and disable certain counters, right? So it's kind of more complicated, right? More advanced. In the end, it provides you additional insights into the InnoDB. Now, not all of them are enabled by default. If you want to enable all of them, you can use InnoD monitor all InnoD monitor enable equals to all. There is also some sort of like more advanced system how you can enable only some of them, if you will. In my experience, InnoD monitor enable all is quite cheap, and if you value that information, you can just run with additional InnoDB metrics name. Performance schema is another very important data source of observability data. This is instrumentation of choice in the recent version of MySQL. What does that mean? Well, that means that if you think about all the observability problems, how to capture, visualize new data, the thinking in the MySQL development team now is, hey, it has to be exposed through performance schema. It has, over years, has more than 100 tables with various data, and it is also flexible, where some information is capture enabled by default, and you can enable and disable more instrumentation, which can be done permanently or temporarily. A thing to remember about performance schema, though, if unlike InnoD metrics, if you just go ahead and say, hey, I want to enable all the features of performance schema, then the overhead may be quite high, right? You may see performance reduction by 20% or even more, depending on your workload, just to count all the statistics performance schema can provide, right? So be mindful. Now, one thing about performance schema is it has a very powerful, though I would say maybe needlessly complicated configuration. Its configuration is also stored in performance schema. And if you look at configuration, we have 5 different tables which contain that configuration. For example, actors tell us what kind of actors, in this case, sort of users, need to be profiled, right? You can choose to instrument only some of the users, right, or to skip certain users from being instrumented. With setup consumers, you would show what kind of consumers, or you can think about that as summaries, which are going to be built based on the information performance schema captures. Instruments corresponds to instrumentation points, right? What are those points in the code where information will be captured? And in this case, you can see what MySQL 8 has more than 1,200 different instruments. 800 of them are enabled as counters, and almost 300 are also timed. Why is there a difference between counting and timing? Well, because simply counting operation is substantially cheaper than also timing it. So in the cases where simply number of events is enough, well, then it may be good to just count and not try to time. Setup objects tells us what objects in the database to instrument, right? And you can see in this case what the default configuration is what tables in MySQL, performance schema, and information schema are not accounted for. and then the rest is. I'm not quite sure why decision was done to do it this way, right? What is the point of hiding some of the system queries, because in some cases those queries can be pretty heavy, but that is the behavior, right? And you need to look at that. And finally, we have also set up threads, which tells us what kind of different threads are being instrumented or not. And again, there are a whole bunch of different internal threads here, which are typically instrumented. The most important one is this thread SQL one connection, which is actually the user thread, right? All the threads which happen your normal work, right, will be of this type, right? And this you have to instrument. Here is example of a raw performance schema data, right, which tells us about event statements current, right? These are currently running statements, right? It has a lot of helpful information here, right? Like SQL text, digest, and so on and so forth. It is also hard to work, right? If you can see timer start, timer end, they have some bizarre, complicated numbers, right? And those numbers are in picoseconds, right? Picosecond is 1,000th of nanosecond, right? So that is a very tiny amount, right? Which really potentially allow for a lot of accuracy, but it also means you have to really do math on them before it becomes easily usable. Now, if you do not want to deal with that complicated math, but you would like to use the power of performance schema from MySQL directly, you can use C Schema. What is a C Schema? These are views and stored procedures to assess performance schema data more conveniently. And it contains views for humans, such as this, and also views for machines. These are essentially the same views, but with X and dollars appended to them. We would have the same columns, but in a better machine-readable format. So here is example for humans. One thing you can see here is what the things like statement latency or current memory, and so on and so forth. They are all converted to milliseconds, kilobytes, megabytes, and so on and so forth. So it is easy to understand. But if you would be writing a script, it will be pain in the butt to deal with those things, right? So if you're running script, right, it's much better to query those machine-readable tables, which, as you can see, would have the same data, but counted in bytes, right, or in picoseconds. It's standard diffuse. One thing I would also point out is what, as you look at performance schema, you have to sort of trust but verify. There are oversight and bugs in the performance schema. Like, for example, in this case, I am looking at the memory, right, which tells me total memory allocated and is 2.72 terabytes, right, which is like, wow, this is huge. Well, in fact, in this case, what that means is what, if you look at the all total memory allocations, they are mounted for 2+ terabytes, right? I'm not particularly, understand what is the value of this data, but what is valuable is the current memory, right? The current memory shows us what the current statement has about 18 megabytes of memory allocated. Another interesting thing, what you may discover looking at performance schema, is file IO by host, right? Which allows you to look at file IO, right, which is attributed to the specific hosts. You'll find though is what a lot of IO will be attributed to a host called background rather than a foreground host, and that is because a lot of activities happen in the background, such as buffer pool flashes, but also because in MySQL 8 you would see log file flashes being done through a background thread, and this latency is no more attributed to the host, right? So you have to really understand the architecture to get use of that data properly. So the next thing you can see this as an example is if you look at the different hosts, is a statement latency, which shows us a lot of helpful data, such as statement total latency, max latency, how many rows examined, affected, and so on and so forth, right? Which really allows us to understand very well where things happen and how performance is happening. Another cool thing you have is you can look at what we can call a statement type, right, from different hosts. In this case, I can see, for example, for different hosts, what kind of statements they have really provided: selects, updates, commit, inserts, which can be quite helpful, right? We can see in this case, for example, what majority of my latency came from select statements, right, from this from a given host. Another interesting thing you can find in this performance schema is file IO, right? You can see in this case, if I take a look at the table, I can see for each of the files, right, which roughly correspond to the tables in my case, because I'm using energy file per table and don't use partitioning. I can see number of reads, number of writes, right, the average write size. I can see wherever I'm getting more reads and writes, which can be very helpful to understand the IO pattern on the low level. Now, if you find that is too low level, you can also look at the higher level events, which will summary all their table files to a single InnoDB data file, right, and give essentially similar information, but on the higher level, right, as you can see. And in this case, I think that is very cool to see how much information, for example, goes to the InnoDB log file versus bin log file, right, and what takes more latency. Next thing I will mention, which comes from performance schema, is memory allocation. In many cases, you will have MySQL consuming more memory than you expected or wanted to consume. Well, this is a tool which you can use to analyze where that memory is spent. And typically, a lot of that will be in the energy buffer pool. But you can also find some other memory allocations here. Some of them are more expected than others. Another cool thing what C Schema provides is the enhanced metric tables. If you look at these metrics tables, it combines the information through show status and energy metrics, and it enhances that information with additional metadata, such as about the type, like in this case we have seen the glow status, or wherever it was enabled or not. And another thing what C Schema has is improved show process list output. The show process list in C Schema is cool because additionally to your normal threads, it also includes a background thread. Like in this case, I'm having there one of the internal threads, right, and I can see what exactly it's doing, how much memory it's allocated, and so on and so forth, as well as obviously much more stats compared to what your normal show process list gives you. Information schema, C Schema, has some other additional tools and scripts which can be very helpful for DBA. For example, one of the very common problems and very bad ones is running into the running out of after increment, right? So basically, when you after increment hits close to the maximum value of a column, then boom, right? Your inserts stop working, right? And now you have to immediately take downtime to extend that column for a larger data type so you can continue getting the data. To avoid that, you can use a statement like this, which now tells us is what in this table we're using only a small fraction of the after increment space, and we don't have a problem. The C Schema also have some pretty cool tools, which you may also have seen in Percona Toolkit before. For example, finding redundant indexes. You can now do that directly from the database, and you can see what it's not only shows you what indexes duplicate to what, but you can also see the command here, which you can use to drop the index, right? Right here. Another thing which we use quite a lot in our performance analysis is table access information, right? Which is very helpful, where you can understand which of your tables have been accessed, how many rows were fetched or inserted, and so on and so forth, right? And also their total latency, which this table had. Very helpful information, right, to understand what are your hottest table from IO standpoint and what are they doing. Now, I mentioned already their feature of redundant indexes. The other problem, what happens with databases quite often, is the load of unused indexes. And that is what you can get now as well, right? So you can look at the indexes which have not been used since the database started. I would be careful, especially with the short database runtimes, of dropping those indexes straight away, but often you can disable at least such indexes before you completely drop them, right? That is one of the newer MySQL 8 features, which I think are quite cool. C Schema also allows you to get their better security by showing, for example, what sessions are using what SSL version, so you can audit your threads, your clients, to make sure they are connecting using SSL, and not just that, but also using appropriate SSL chipper and so on and so forth. Statement analysis in C Schema is the better view on the statement digest table, which shows us different statements and various execution statistics. So, for example, in this case, you can see show global status is actually, to maybe your surprise, creates a temporary table, right? And we can see what number of times it was executed, which is 240,000 times, right? Each of them required a temporary table being created. Another thing which is using the same data, but is kind of more convenient, is looking at the statements with errors and warnings. Like in this case, we can see what this given statement, right, select for update, was executed so many times. 7 of those were errors, right, which is like a very small fraction of percent, and so on and so forth. Often that can be very helpful to understand what are the new queries appearing which have terminated with tables and why. We have showed a lot of information which corresponds to a different hosts, but often it's very handy to be able to look at the information on user-by-user basis. And in this case, you can, right, in terms of getting the summary. As you can see, in this case, we have user summary, where for given user, we can see how many statements that user ran, total latency, and so on and so forth. Additionally, you can look at the globally weights. Like in this case, we have raw weights of an individual log file, handler, and so on and so forth. Right? You can maybe even have some sync events here. I would point out though what as we are specifically sorting data by total latency here, only events which have been timed in performance scheme, right, enabled for timing, will be seen, right? Otherwise, for untimed events, you may sort of do order by total instead of total latency, right? And then you will get the data with error encounters. Now, one of the great things which I like a lot, which was added in MySQL 8, is the latency distributions for queries, right? So before that, you would have a statement digest table, which will have for every very part information. Oh, this query was executed so much time, and the average was X. But averages are not very helpful, especially when you have a query performance which varies. The statement histogram really allows us to get their data by different buckets, right? Where you can see with a lot of details what was the distribution of a query performance, and what is especially interesting, how it changes over time, right? How maybe you're starting to get some of a particularly slow query, and so on and so forth. Okay, with that, let's look at some other things what exists in MySQL beyond the performance scheme. First is there are logs. MySQL supports with error log, general query log, and slow query log. Right? In generally, they are all can be configured in various ways. I would just also point out, if you're running Percona server for MySQL, there are some additional options, such as, for example, Percona server support sampling. So let's look at an example of a slow query log, in this case from Percona server. You can see what it contains information about the query itself, its timing, as well as potentially some additional performance detail. If you look at MySQL 8.0, you now also can enable extended slow query log, which will log additional information out there, such as rows examined, bytes received, bytes sent, and so on and so forth. Right? This is sort of similar information to what you are getting in the Performance server, but it's great to see that also made available in a standard MySQL. Right. The next observability in the feature to cover is explain. Explain really helps us to understand the query execution plan, and this is a very essential skill for both developers and DBA allies. Right? It is very important skill. In MySQL 8, explain has become very powerful. You can have a multiple explain output, as well as you can use explain for connection to get a plan for actually running query. Let's look at explain in a little bit more details. If you're looking at the basic explain, such as displayed right here, you'll get some basic information about what tables are being accessed, what indexes are accessed for them, right, and so on and so forth. And it is pretty good, right, for troubleshooting rather simple queries. It is, however, not very powerful if you want to use something more complicated. The other format which MySQL support for a few versions now is explained in JSON format. And you can see if you have it explained in JSON format, you are now getting much more information available for the same query, but it is also kind of ISO, right? It's not very easy to read, and it's best used with tools like MySQL Workbench, which allow you to visualize a JSON explain in a visual form. If you would want something in this case which has more data, similar to JSON explain, but which is easier on your eyes, you can use tree formats, right? Available in 8.0.16 plus, which gives you, I think, much more usable and readable explain output. So finally, in MySQL 8.0.18 and later, we got a feature explain analyze. And what feature does, it actually executes the query and then gives us the actual data about how that query was executed. You can see the format is kind of similar, right, to their tree-level explain, but now we are having information about actual rows and actual loops and so on and so forth, right, which happen, not just estimates. Even more advanced feature to cover would be tracing optimizer. In some cases, you will run explain and you can say, well, you know what, this plan MySQL chooses just absolutely make no sense. Why the hell is it doing that? And you can discover it, right, by using this optimizer tracing. What optimizer tracing does, right, is what it allows you to enable the optimizer trace when you can run your query, and when you select from information schema optimizer trace, which will give you information about what optimizer has done and why did it make the choice it made, right? So that's going to be very helpful for tuning the query. Okay. Now, if you look at this older information which is available in MySQL 8, it's very helpful, and I show you how to use that from command line. Now, there are a number of tools which exist out there which can also visualize this information. And we have also our own tool at Percona called Percona Monitoring and Management. This is our open source database focused observability solution, right, which you can check out. It really provides you a lot of insight. For example, you can find which queries are causing the most load on your system. You can find why are they causing that load, right? For example, this given query spent 98% in a log time, so probably that's something you need to look at, as well as how to improve your performance, where we are giving you all kind of information on the single page, which can hopefully help you to optimize the query. We also have information about the system performance, like CPU usage, saturation, I/O storage, swapping, and so on and so forth. Remember, in the start of presentation, I was saying how it is not enough to look at just MySQL. You also need to look at hardware and operating system, and PMM provides that, right? You can look at MySQL summary gets some of the most important status out there. We have a very in-depth analysis dashboard for performance schema, right, where you can really go deep and examine specific events, how they have been trending. That can be very helpful in the advanced troubleshooting cases where you find that there is, let's say, some certain event which is abnormally high, and you want to look at the history of that. As well as there is a very deep InnoDB insights, right? I think if you look at that InnoDB insights, that dashboard, that is perhaps the most advanced you'll find in the industry. It goes in a lot of advanced depth out there. And if you're not really ready to set up PMM just yet, you can also just check it out on this demo site, right? See it live without installing that. With that, that's all I have for you today. Thank you, and back to the conference.
Good morning, Peter Zaitsev. Welcome to MinervaDB Athena 2020. Good to have you here, man.
Thank you. Thank you.
First of all, thanks for registering for this talk, for your time, and your deep interest in educating the community. Your book, your blogs, your core commitment and tools has really accelerated and fueled the MySQL ecosystem. Thanks for that, Peter, first of all. When we were working on identifying some of the talks, our committee was quite curious to know about how MySQL 8 observability is going to look different when you compare with the already existing tools, like MySQL performance forensics ecosystem is quite broader when compared to the rest of the open source database systems. There are a lot of community powered tools like Percona Toolkit. There are log files. There are like audit logs. Again, there comes the time series performance monitoring ecosystem from companies like Percona monitoring tools, and extended plugins on Grafana. So this makes already the system quite really good, rich. How do you see that the new observability ecosystem is going to complement more and empower the DBAs?
Yeah. So if you look at observability ecosystem, right, as you mentioned, there are kind of number of different areas, right? One of them is the source information which you can get from the system what you monitor, right? And that is what my talk is about. Now, as you get that information, then you can use multiple tools to process it, to visualize it in different ways, right? You can use different time series store to store it efficiently, right? Then hopefully you can also use some tools to do anomaly detection or some other things how you process this data to actually give folks actionable advice. And if you look at that, all of those ecosystems are very evolving rapidly with many new tools, approaches being developed, right? But at source, really at source starts the raw data which you need to capture, because if you don't have that information, then you can't really build any tools which rely on that. And that is where MySQL 8 has done a significant step up compared to the previous versions.
Okay, so when I look forward from a DBA's perspective, right? Today I look forward for two major areas on the observability ecosystem. One is about how is the response time metrics on the queries, on the performance. Another one is about throughput. So when you're looking at MySQL 8 observability, how much percentage of this is being solved on a throughput monitoring compared to the query response time? Do you have some metrics like that to share with us, sir?
Oh, yes, of course, right. And what you're saying, I think this is where it goes on a high level, right? You can look at the query response time, and MySQL 8 adds the query response time histogram, right, based on the query
Mhm.
times, which I think is a very powerful, because in many cases, the average query performance is not what you're concerned, but by
Mm.
having some outliers which give you a problem, right? But now this is where, if you look at the whole process, right, it often does not stops with, oh, I have a bad throughput or some queries which don't perform well. Uh, the next question becomes why, right? You often need to figure out what has been causing that issue, and that is where a lot of additional information can be helpful, right? In terms of performance schema information, right? Or tools like optimizer trace, which can help you to figure out, for example, why a hell the optimizer is not picking the plan which you think is optimal for that query, right? So there are a lot of those different tools now become available.
Mm. Mm. And how much of this is going to PMM now? Just being curious, because if you look at Percona monitoring management console, quite catches up closely with the developments happening on the performance schema improvements happening from uh, MySQL. So how much will be visible for a DBA? Like DBA can get a lot of information from a SQL console, but how much of this will be on
Well,
PMM now?
yes, you are absolutely right. Our plan is to continue expose more of that information in Percona monitoring management, and also use that in other tools. Some of
Mm.
that information is already exposed and available, but there is also some other information which we still have yet to add, or which community has yet to add, right? That is the power of open source projects, is what if the company kind of like Percona cannot move fast enough, right? Community can contribute and help for something which they need.
Understood. So if you look at from a DBA perspective, right? Imagine I'm looking from a MySQL DBA perspective. What
Mhm.
will be the top three MySQL 8 observability you recommend should be on their checklist to troubleshoot? If I'm purely looking on the MySQL 8 observability, features, not
Yes.
looking at anything. Yeah.
Well, I mean, in my opinion, if you look just at MySQL 8 and the
Mhm.
new stuff which appeared in
Mhm.
MySQL 8, that would be the following. The first one, which I mentioned, would be the query histogram
Mhm.
response time distribution, right? Which is kind of very
Mhm.
powerful, allowing you to find specific outliers. The
Mhm.
second would be the tree explain format, which is available in MySQL 8.16, which is kind of a mix between kind of, in the past we had a basic explain, right, as a table, which is simple to read, but it will lack a lot of details. And then we would have a JSON explain, which is a very powerful, right, but which is very kind of hard to understand for human, right? You actually need to use some other tools to do that. The tree format really sort of combines the benefits of both them, which is simple to read, right, in its normal output, as well as provides much more details than a basic explain. And the third one would be explain analyze, right? And what explain analyze does, it allows you to actually run the query and compare what was expected versus how expensive a query run really took, right? And for many queries, especially some pesky queries, right, that is extremely powerful to understand why they are not running very quickly.
Thank you. So if I understand from what you say is like so far, if you look at till MySQL 5.7, the visibility was quite direct. When I say quite direct, it was about, hey, I'm running a MySQL infrastructure. If I'm finding a performance bottleneck, I have set up logs like slow query log, or if I'm using an audit log, interpret that, have performance schema, find out that what is the system resource distribution across the query execution. And today that is been getting much more broader. One is that the interpretation has been changed with the query histogram to the query explain histogram. One is that. The two is that, like, me as a DBA, I'll be more intuitive. The percentage of the assumption which I keep discounting when I troubleshoot is getting more thinner and thinner. I have a broader forensics report available to troubleshoot more effectively the performance. Did I understand you rightly?
Oh, yes. I mean, MySQL 8 has a number of additional more powerful features. I wouldn't go that far to say, hey, you know what, everything before that was crap, right? I think MySQL observability was actually improving in every version since as far as I remember, right? And that is I would say, ever evolving process, right? And I think that is also connected to a MySQL, which is increasingly being adopted in more broadly in more of enterprise environments rather than more complicated applications, right? Where often more observability is desired. Another thing which I think is very interesting is this drive by Oracle, but as well as by other vendors with a database as a service deployment model, right? Because if you think about this model, that means what you do not really have access to their instance directly, right, to the operating system. You are expected to interact that through the native protocol and SQL as a language, right? So you are not expected to go ahead and use, GDB, right, or some other pprof, right, or some other advanced tools you may like to use, right, which pushes up requirements for built-in observability features.
Yes, this means there is a lot of flexibility now that comes with there are some threads also. I don't call it threads. There have been like pitfalls. Like when I have access to quite a lot of information, if I'm greedy, like I just go ahead and enable all the performance schema variables to be super obsessed by collecting the information. That will eventually turn out to be a bottleneck for my MySQL performance. Do you have any recommendation for a DBA, like what they should be careful on when they are tuning system variables of performance schema, not to create a bottleneck for the database?
Yeah, well, that is a very good point, right? If you look at defaults in a performance schema, they are suitable for for normal monitoring for majority of workloads, right? You can just keep it enabled without losing too much on performance, right? I would say when you are experiencing some performance problems, you
Mm-hmm.
may want to ratchet up to enable more instrumentation, right? And this is typically how I see that. There are certain things with general kind of observability which you run in production
Mm-hmm.
so you can always kind of go back and say, hey, what happened yesterday, right? When things haven't been working correctly, right? And have a lot of data for that. And then there is something which you can use for diagnostics, debugging, right? Maybe you have a canary instance, right, which has more instrumentations, which can give you more insights when you need
Mm-hmm.
it, but obviously at the higher cost, right, higher overhead.
Perfect. So that's all the questions from my side. So thanks again, Peter, for giving us the clarity on MySQL 8 observability. Thanks for your time. Wishing you in advance Merry Christmas, belated Thanksgiving, a great 2021 for you, Peter. Looking forward to
Okay.
talking to you again.
Well, thank you, Shiv. Thank you for inviting.